360 Dash has been designed to save you half or even as much as 2/3 of the starter you're applying today by giving you precise control over where we apply relative to the seed. And that may sound complicated at the surface, but we want to take some time to dive in through a series of videos to look at the different components of the Dash system. What are the components that are at the row? What about the components that are at the center of the planter, your pump tower, your filtering, your ability to control the system through an iPad? All of these are going to be different chapters in a series of videos that we're going to walk through all the components of 360 Dash, where you'll see really how simple it is. 360 Dash has been designed to give you complete control over your ability to apply starter on the seed while saving as much as half or even 2/3 of the cost. And that may seem complicated at the surface, but we want to take some time to walk through the components of the system, and as we start to bring this all together, you're going to see how simple it really is. The centerpiece of the Dash system is the valve itself. It has the ability to respond very quickly and control the rate that's being applied as each seed passes through the seed tube and into the furrow. The Dash system is designed with the valve to connect to a flow meter, and you have several choices of flow meters that can be used. There's the 360 flow meter, and the same type of technology is used in the precision planting flow sets. Both of these are an option that works with Dash. At the same time then, there's some plumbing that you'd have that connects through a check valve as well as a row filter. We then connect the valve through a series of harnesses, one harness for a speed tube or a precision planting system, and then this harness is used when we're on an ExactEmerge or a John Deere system. We'll show you a bit more of the detail of how those work. On the outlet of the valve itself, we pass the liquid through our outlet hose. This hose is specially designed to work with Dash. We'll talk more in a later session about its properties, but it's designed to maintain good quality shots all the way through to our applicator. And there's a number of choices of applicators that can be used. In this case, this is a low pro Keaton seed firmer. So all the components you see here go together at the row, and I'll just start to show you how they connect together. So you'd start with the valve itself. We have our bracket that mounts to the row unit, and then that bracket snaps directly onto the valve itself. So as we put those together, latches in, so we would have the valve mounted in our row unit. From there, we'll go ahead and connect a section of tube into our inlet on the valve, and then we're ready to connect to a flow meter. So I'll set the flow sense aside. In this case, we'll use the 360 flow meter, connect it here, and then we'll have a shorter section of hose that connects to our check valve. And the purpose of the check valve is to maintain consistent flow through the flow meter so that we always have an accurate reading. And from there, we would then connect towards the front of the row unit at our 7x7 bar to our row filter. The row filter itself has a fine mesh screen, and this is in addition to the filtering that would happen at the pump tower on your planter, where you'd have more your standard filters. This filter's been designed to protect the flow meter, so we know that there's different types of particles coming through, especially starters, and by filtering at the row, we can protect our flow meter and the delicate components that can come in that. So from there, we connect our row filter again at the top of the bar. So at this point, all the plumbing to the valve has been done. Now let's look at our harness, and to use an example, I'll use the precision harness. This connector, the green connector here, connects to the valve itself, right here at the top of the connector. We'll plug that in. This is very simple. You'd connect the blue connector to your can extension and your precision system that's at the front of the row unit. And depending on which flow meter you use, you may or may not need this connector. In this case, because we're using the 360 flow meter, we would plug it in. If you were using a flow sense, that's already coming through the can data on this side of the harness. So I will take the cap off because I'm using a 360 flow meter, and you can see the connector here goes right together. Okay? If you're working with a John Deere planter that has the ExactEmerge high-speed system, you would use this harness to plug in 360 Dash. The large connectors go at the parallel arms where these connectors are found today on the Deere system, and we break into the middle and connect to both sides. Then as you follow on down the harness, again the green connector connects to the valve. The triangle-shaped connector goes to the flow meter. And then these two connectors are used to connect to the brush belt. And we do that so we can get our seed signal. In this case, the longer connector goes down into the row unit, connects to the brush belt itself, and this connector plugs into the deer harness where the brush belt would typically be plugged in. So by breaking into here, we can get our seed signal. With both harnesses, we're picking up power off of either your Precision or your John Deere system to run our valve and to run our flow meter, and we're getting our seed signal. And then from there, our ability to communicate with the valve is done wirelessly, and we'll talk about that in a later chapter. So at that point, all we're left with is our outlet hose. It goes on the outlet side of the valve itself. It would be routed through your row unit to your attachment that's applying in the furrow, or in the case of wave, near the furrow, and you'd see we're connected there. At the end of the firmer, or the wave blade, we have our outlet orifice. And we'll talk more detail about what that orifice does for us, but it's an important part of the system. And in this case, it's centered right over the seed, and we know the exact position that the liquid's going to be applied in the furrow so that we can time it correctly for the seed itself. So as you can see, from the front of the bar, working our way to the flow meter, into the valve, connected through our harness, out through our outlet hose into the attachment, these are the components you would have at the row unit for 360-. So this is the first chapter in a series of videos that's going to walk through the entire system on 360-. Here we've looked at what's at the row. We'll also be looking at the pump tower and the components that are at the center of the planter, as well as talking about how do you set rates and how do you set up the iPad to control the system. In this chapter, we want to dig into the 360- valve itself. We're going to break it all the way down and show you all the components of the valve, talk about what the wear parts are, and talk about how each piece functions to be able to deliver the performance that we're looking for. So as you look across the valve itself, on this side you have your inlet fitting, it's push connect. On this side of the valve on the end is our outlet, where the dash itself comes out of the valve. We have an outlet pressure sensor on this side, and this is mostly used as a diagnostic tool. We record the data that we see that's telling us how is the behavior of the liquid changing as we create dashes through the outlet hose coming out of the valve. So this gives us a good idea of what the quality of the dashing is. As we work our way through the valve itself, here under our cap we have our circuit board that's potted in with our connector, where we can connect either our Precision or John Deere harness. Again, on the top of the valve you see our LED that gives you a good indicator of what state the valve is in. We have our Wi-Fi antenna that connects us back to the hub. And as we come to the back of the valve, we have our accumulator. So I'm going to go ahead now and use the screwdriver. All the parts of the valve come apart very easily with a Phillips screwdriver. And we'll start here with our outlet cap. There's 4 screws. I'll go ahead and take those apart here first. These are self-tapping screws. We've had them in and out lots of times with no issues. You just want to be a little bit careful as you tighten them down that you don't strip out the screw itself. And our last one here. So this is really the business end of the valve itself. As I pull the cap off the end, it's sealed here by an O-ring. And I'll disconnect our pressure sensor connector right here on the side, and we'll be free. So now, as you can see with the valve, you're looking into the internal components where the rate is actually set. And here on the outlet cap, you can see here this white insert, and that's our outlet orifice. So the rate itself is set right across that white piece by changing the position of this plunger. You can see the tip of the plunger here sits inside of the outlet orifice, and the valve works by pulling back on that plunger, and the more we pull back, the higher the rate, and the plunger itself is able to move very quickly. In 12 milliseconds we can open fully, and in another 12 milliseconds we can close. So the valve moves very quickly, and we can respond that way to high speed. I'll take the opposite side off now. This is the accumulator, and its function is to dampen out the shot. So each dash starts and stops the fluid flow through the valve. But by having an accumulator on the back, we dampen all that out and create a more consistent stream passing through our flow meter. So it's same types of screws here, Phillips screws. And we'll pull off the accumulator cap, very simple. And then there's the inner piece as part of the accumulator. And again, just sealed by O-rings. So now we're down to the main body of the valve, and I'll pull out the plunger. So the wear components in a valve are the plunger tip and the white insert. And those two, as I mentioned earlier, are setting our rate. So the magnets here on the center of the plunger are pulled on by a coil that's in the main body of the valve, and that changes the position. So we're able to pull back on the plunger and hold it at a steady position, and then as soon as the dash is done, we're able to quickly shut that back and close off the flow. So by changing the position for each seed, we open it up, hold it to a set position that sets our rate, and we quickly close it back and seal it off. So the wear components are the plunger itself and the outlet cap. The insert itself is not replaceable. The entire cap is replaced. So these two components, separate of the pressure sensor, are your wear parts. We see these going in the order of about 10 million cycles. So quite a few cycles, and it's basically one cycle per seed. For most of your planting populations, you're going to see that be 3+ seasons. What we see as the parts wear is our minimum rate in the valve creeps up slightly. So if you were running 10 gallon per acre concentration, you're actually going to find that you can get more wear life out of these parts than the numbers that I've mentioned before. So now we'll go ahead and take our pressure sensor off. So as you were going to replace the cap, we would keep our pressure sensor and put it on the new cap. Again, it's 4 small screws here. The pressure sensor lasts a significant number of cycles, more than what you're going to ever get to in the life of a valve. So we don't expect this to be a replacement part, but it can be removed, and when you go ahead and replace your cap, you will use the pressure sensor off the old one, take it off as I'm doing now, and put it on the new cap. It's fully self-contained. Once I bring it off here, you'll see all the seals and everything are built into the pressure sensor itself, and it mounts up to the plastic ring that's here molded into the cap. And again, this pressure sensor is a diagnostic tool. It's measuring the outlet pressure, not the inlet pressure. It's measuring the performance of the valve in the outlet hose and making sure we're creating consistent shots at the right time and that they're good and crisp. So the pressure sensor itself will place here. This would be your replacement component as well as the plunger itself. Then of course you have the main body of the valve, and you have the accumulator giving us a consistent stream for our flow meter. We've taken a look at the different components of the valve, but let's just go through the process that you would do to replace the wear parts. So as I've described earlier, the cap itself is replaced as well as the plunger that's in the valve. So to start with, we'll remove the plunger from the valve. We'll call that our old one. And we would provide a new plunger as part of our wear kit, so I'll just simply slide that back in. And you can see the magnets are attracted to pop right into the valve where it should be. There's no preciseness here. The plunger itself is going to land in the right spot. And then from there we'll have our new cap, that's our replacement. And at this point you would have your pressure sensor off the old cap that's been removed that we're going to go ahead and install here. So 4 screws would go ahead and install the pressure sensor on the new cap. Just 2 more. The connector faces to the rear of the valve, opposite of the outlet fitting. Okay, got that tightened down. Now the connector on this side of the valve obviously lines up with the pressure sensor connector. There's an O-ring seal around the outside of the cap that you'll be able to quickly feel when that pops in. And I'll actually start by putting this connector together. That's snapped in. We'll just line it up here with the end of the valve and just press the cap on. You see it goes on fairly easily all the way around. And you can see then our outlet, or our inlet actually fitting, is here on the side of the valve facing to the rear. And now we'll just have our 4 screws lined up here to go back on. And we'll tighten those down. Again, these are self-tapping. There's no need to over-tighten them. The O-ring seal does the job for us there. Put 2 here on the bottom. Snug those down. And we're done. Fully reassembled valve. For this chapter, we want to spend some time looking at the different attachment options that are approved to work with 360-, as well as spend a little bit of time talking about the outlet hose itself. So in this case, we're thinking about everything that happens downstream of the valve. As you can see here, we have our 36-inch outlet hose, and the material of the hose itself has been tested by us to have the right amount of stiffness to create clean and crisp dashes. We're looking for a crisp start, get up to the rate that we want, and then a crisp stop. And the mesh that's built into the wall of this hose does a good job of creating that kind of dash. So we recommend you use the hose that we provide. As we think further then about your choices of attachments, for each attachment, we've spent the time doing the testing to confirm that it meets a number of different requirements that we then know it's going to work well with dash. So I'll just use one of the firmers as an example. To start with, we need an outlet orifice at the end of each type of attachment. And we're looking for the orifice that's provided by either Precision Planning in the case of a Keaton seed firmer, or Flow-Rite for the Flow-Rite firmer, or with 360 Wave, we've developed the end of the blade tube to have the correct size. In each case, we're looking for about a .110 orifice. We're also using, in the case of, say, the Precision tails, generally what is the blue outlet orifice that is the single stream aimed directly at the seat. In many cases, the different firmers offer some form of a split orifice, and this we've found to not be able to produce crisp shots, so we do not recommend that you run that. Instead, we're going to run any of the choices that gives us a straight stream onto the seat. So the first thing we're testing for when we approve a new attachment is that we can get you an outlet orifice that does the job we're looking for. And that is to basically keep the entire hose from the end all the way back through to the valve itself. We want to maintain liquid in that full length of hose at all times. What we're looking for is that the valve opens and immediately thereafter liquid starts to come out of the orifice. So the orifice itself keeps our tube full. So that's step one. The other thing that we look at is your delay timing. And we need that so that we can consistently hit the seed. If you might think about this firmer running along in the trench, we then know where the seed lands in your row unit, depending on whether you have the brush belt or the flighted belt system. But then we need to know the length of the tail as well as the angle that this outlet orifice is pointing so that we know exactly where the shot lands on the ground. We're then doing the math behind the scenes based on your planner speed to know exactly when we should start the valve and when we should shut it off to create, say, a 3-inch dash or whatever setting you've picked. So the length of the attachment is important. And when we do our testing to approve a new attachment, we're looking at where does the seed land and where does the dash land. And that is then based in time behind a setting that's in the iPad itself. So in your settings page, under planter, we have here your applicator. And in that list, we have each of the different attachments that you see here on the table. The Flow-Rite firmer, the Low Pro, Standard, No Stick, and Smart firmer from the Keatons from Precision, as well as 360 Wave. So depending on which of those you're running on your planner, you'll go ahead and select, let's say 360 Wave in this case, and that now tells the dash system exactly where the end of the tube is in your row unit, so that as you're traveling across the field at whatever speed you might be running, we know exactly when to start the valve to go ahead and consistently hit the seat. So the length of the attachment is important, as well as having the approved outlet orifice.
In this chapter, we're going to talk about the wireless communication and the 360 iPad app. So we're going to start here with the valve. and they are wirelessly communicating back to the hub, and then the hub is wirelessly communicating to the iPad app. So let's take a look at each of those. Okay, so we'll launch the 360 app, and the first time you launch the app, the iOS is going to ask you if you would like to let the app send you notifications. And we use notifications in the app to alert the operator to important alerts that are happening back on the planner. So we encourage you to allow. And then next, the app will ask you if you would like to approve the 360 app using Bluetooth. And like I mentioned, wireless communication, we need to approve this, click OK, and that will allow you to connect the iPad to the hub. So you select the hub from in the app, pick your hub from the drop-down, and now it's connected wirelessly. We can take a look at the first step, which is going to be setting up your planner. When you first get started, and after you connect to the hub, go to Settings, and first step is going to set up the planner. So we need to select the number of rows. We only have one row here, so I have that selected. Next, the row spacing. That'll be the row spacing on your planner. So let's say we have a 30-inch planner. Next, we need to select the seed sensor used. And for this demonstration, I will select the speed tube from Precision. And as previously mentioned, the applicator. And the reason we need to know the applicator is to select the correct delay. We have all the different options here, and we'll just leave 360 waves selected. And also, last, for this selection, we need to pick the pump type. And we'll leave that set to electric. The next step is a process we call row ID. And the reason this is necessary is because all of our valves are communicating wirelessly, which means that we have no idea which row they're on. And this process that we sort this out is called row ID, and you initiate that through the iPad as well. So we'll select row ID and start row ID. And we have a little demonstration here about how to use the provided magnet and where to place it on the valve. So we'll start row ID. And you can see that the light on the valve changes to a stutter. And that lets us know that the valve is in row ID mode and is ready to be placed on the correct row. So you'll start behind the planner, row 1, furthest to the left, and you'll simply place the magnet on top of the 360 logo. Wait just a second. You'll get confirmation in the app, and also you'll notice that the LED changes to a slow flash, indicating that it has been successfully row ID'd. Then you can move on to row 2, and as you continue to move all the way to the right side of the planner. When you've completed that process, all the valves should have a slow flash on the LED, and you can select Done. At the top of the screen, you will see that we have successfully row ID'd one of 1 row. There are 2 status LEDs on the hub. We get the top one, which is iPad status, and the lower one, which is row status. Currently, they're both slow flash, and this is the correct flash pattern for when the iPad and all rows are connected. If the iPad or the rows are not connected, the appropriate LED will exhibit a fast flash, indicating an error state. After we've completed the row ID process, the next setting we need to look at is liquid. And here we get to select our dash type. If you're going to run it in dash mode or in stream mode, we're going to leave this dash mode for now. And next we want to select the dash length. So this is the amount of time that the valve is open and the length of the shot that will be placed on top of the seed. I have mine set at 3 inches. You could also select 2 inches for more savings. I'll select 2. Next, the flow source. The 360 dash system can read the flow from both the 360 turbine or from the Precision Flow Sense. I'm going to leave mine set to 360 turbine. Now that we have the dash system set up, let's take a look at the run screen. We see that we're connected to a hub, and here we're simulating 24 rows. The system is on, and it shows that we have used 330 gallons, and that's being measured by the flow meter at the hub. We're currently using 1.7 gallons per minute, and the system right now is controlling 26.8 psi. See, the next two boxes are yellow, and that's because these are simulated right now as well. The dash system is applying approximately 18 shots per second. That's one for each seed, and that's averaged across the whole bar. And we are traveling a simulated 6 miles an hour. Over here on the right is where you actually set your target. So we are currently applying a local concentration of 7 gallons per acre. And you can see that confirmed here that that's what we are actually applying. Because of our settings and because the way the dash system works, we're actually only using 2.3 gallons per acre, which results in a savings of approximately 66%. Over here on the left, just a quick refresher of the settings. And this is actually a shortcut if you want to get to the settings menu. And you can get back home. Just under settings, we'll show you some alerts. It's flashing red right now because we're on a simulated system. And then under that, across the bottom, you'd be able to see a row-by-row view of the flow. And let's say this would give you an example of perhaps a plug or a low flow, something that you'd want to take a look at. And you can do that by clicking the See Row Details. Here you can see all the rows again, and it will let you dive in to the particular row that you're interested in. Here we show you all the diagnostic information. And this really gives you all the information you'll need to figure out what's going on and give you the confidence that Dash is working great. In this chapter, we're going to talk about the pump tower and plumbing. And here we have the Dash Ready system from AgExcel. This is their electric option based on their GX2 platform. They also have a hydraulic option, and that one is rated for up to 19 gallons per minute. And we can talk about some of the things that will help you decide which one is right for you. Something that would make the electric option very attractive would be for a smaller planter, something less than 60 foot wide, and something that's going to run for no more than a roughly 5 or 6 gallons per minute. Also, it's well known that the electric option, although it is cheaper, you might be replacing the electric pumps more often than the hydraulic option. Another reason that the electric option would be good for you is if you are out of hydraulic flow on your tractor. Obviously, the electric option is going to run straight to your battery. Something that would make the hydraulic option necessary is if your flow rates are above the 5 or 6 gallons per minute, or if your bar is 60 foot wide or greater. Also, you might prefer the hydraulic option, has more flow capacity, also likely to last quite a bit longer. Both electric and the hydraulic options, because they are dash ready, will have the same flow meter, pressure sensor, on-off valve, the same filters, and they will have all the same connectors. And that's really important because the dash system will control all the components here and read in all of the signals. And that way they'll be compatible with both the hydraulic and electric options. Let's take a minute to talk about each of the components that we have asked AgExcel to add on to their base platforms for the GX2 and GX5 system. So we'll start with the flow meter, and the flow meter is necessary so that we can monitor total flow for the system, and we report that back to the operator through the iPad app. We have the pressure sensor, and this monitors the pump pressure, and that's actually primarily what we're doing the control on. We want the pumps to deliver a constant pressure to the system so that the dash valves can operate properly. We've also supplied the garden hose fitting, and that just allows you to clean out the system more easily when you have extended downtime. The on-off valve here is really just a convenience feature, and that way when you're done for the day or in between fields, we will close this valve automatically, and that will prevent any of your starter from leaking out if you perhaps forget to close the manual valve in between fields or when you're done for the day. And like I said, both of the GX2 and the GX5 kits that are dash ready include all of these same components. If you have recently purchased a GX2 or GX5 system from AgExcel and you are ready to make it dash ready, you can talk to them and they are aware of all of the components that we require, and they will be able to provide you with the components necessary to make your existing system dash ready. And while you have them on the phone, you might take a minute and ask them what other components that they provide. They have a big selection of plumbing components for the rest of your system because the dash system does not provide the plumbing from the tank to the tower or the tower to your rows. So that's something that you could get from them as well. Let's take a minute to talk about the best practices for plumbing your planter. When it comes out of the on-off valve here, we recommend a single wet boom style plumbing for your planter with a T for each row, and this will let us supply a constant pressure to each dash valve. Now that we've talked about the pump tower itself, I want to mention where we prefer that it's mounted. Because the hub attaches directly to the pump tower and the hub communicates wirelessly to all of the rows, we would like the pump tower mounted as close to the center and as close to the bar as possible. Let's take a look at the hub. I've got one right here. I've got the hub itself and then the hub harness. And earlier I mentioned the importance of having the components that make it dash ready, and part of that includes the fact that we know what connectors to expect, and we've supplied all of the mating connectors here. I'm going to turn this around and start to plug some of these in. All the connectors on the pump tower are unique except for the two pressure sensors, and the way you determine which is which is you trace the wire back. So let's start here. Here we have the inlet pressure sensor, and you'll know it's the inlet because it's immediately under the inlet fitting. Let's trace that back. We'll set that here, and that will mate to the connector on the harness labeled pressure 1. That means the other one, and you can confirm, is traced back to the pressure sensor on the front side, which is immediately under the flow meter, and that one gets plugged into pressure 2. We have the harness for the on-off valve. And then if you trace this back, this goes to the flow meter, and it plugs into the connector labeled flow. Then we have a 2-pin connector here labeled PWM, and this plugs into the 2-pin connector on the front here that is on the motor controller. On the electric pump option, we use the motor controller. On the hydraulic option, this will plug directly into the solenoid valve. We have 2 remaining connectors. We have the connector labeled power, and this one will plug into harness 550822, and that will get power from the battery and from the key. That way we know when to open and close this valve if by chance you forget to turn it off on the iPad. When you turn the key off, we'll automatically close this valve for you. And then we have another connector here for CAN, and that's currently not used. Okay, I mentioned this power connector here, You'll notice there's 3 wires. The hub harness needs both battery and key power. Unfortunately, we need both, and that way we can close the valve in the event that you turn the key off without turning the system off in the iPad. When you turn the key off, it will automatically close the on-off valve for you. I have one of those harnesses here. This is the 550822 harness. It does have the 4-pin connector here that plugs into the harness connector labeled power. And then we get battery power here from this 2-pin splitter. And on the electric system, this splits the power harness that comes from the AgXL harness to your pump controller here. It's a large gauge wire. So you'll plug that in and then plug the AgXL harness into here, and that will give us battery power. And to get key power, we're going to run this harness right here back to the nearest row. So since we mounted this roughly in the center of the planter, there should be plenty of harness length to get you to the nearest row. I just want to show you where that splits in. So I have the dash valve here with the precision harness and the flow meter plugged in. So we have the 3-pin connector here. We're going to split that apart. We're going to plug the flow meter back in, and then we're going to plug this harness into the flow meter harness. And that will let us get key power up to the hub so that we can control the on-off valve and power all of the sensors, but it also passes through the flow meter signal to your dash valve. In this chapter, we talked about all of the components and the features of your pump tower. We also briefly mentioned the features of the hub. In another chapter, we will dig deeper into the components and the features of the hub itself.
So for this chapter, we want to spend a bit of time thinking about how you set the rate in Dash and how you should think about that rate. As you saw on the home screen, there's 2 numbers here. There's the 10 gallon per acre in this case that matches the target that we've set in the app, and we call that dash applied, and we mean that as the local concentration that's near the seed. And then here on the other side of the app, you can see what we call tank usage, in this case 5 gallon per acre, and in the middle we show you that's a 50% savings. So what do these numbers mean, and how do you know what number to put into the app as your target rate? So let's use some examples here on our flip chart and start with an easy example where we would put seeds, let's say an average of 6 inches apart. And in the past, prior to using Dash, we're going to assume that you applied 10 gallon per acre. And you're doing that, of course, in a constant stream, maybe on the seed or near the seed. And as we now think about using Dash, we should think about concentration near the seed or on the seed instead of thinking of it as a stream. In this world, you're obviously using 10 gallon per acre. That's how much your tank is going down. So let's then compare that though to a situation where we're running Dash. So now we'll have the same seeds, again 6 inches apart, but let's think now that we have the app set to a 3-inch dash. So half of the time we're going to be on and half of the time we're going to be off. When in the app you set the setting here, your target rate at 10 gallon per acre, you're telling us that you would like the root system on this seed to see the same kind of concentration that you would have in the past when you applied 10 gallon per acre as a constant stream. So we'll say that in the app, you've told us 10 GPA is your concentration target. If you think about how the root system is going to develop on this plant, we're going to get the intercept that we're looking for. That's the whole concept of Dash, that we're getting a great ROI on this starter, and we've had the ability to save the 3 inches in between. So now your tank is going to go down by 5 gallon per acre, and that of course is because we're applying 3 inches out of every 6 inches. So that ratio, 1/2, means that our concentration is still 10 gallon per acre here, but our total usage across the field is in half, 5 gallon per acre. So you have several options then as you think about, do I want to save starter and make that my primary goal, or do I actually want to invest more? And that would be an option as well. So let's look at another scenario. Again, we'll keep our spacing at 6 inches because it makes the math easy. So you may say, you know what, I actually want to now come back and take the starter that I would have applied here, and I want to double it up. I want to take the 3 inches that would have gone in the middle and put it on top. And you could do that. In this case, then you would say, I want 20 gallon per acre concentration, actually doubling. And you're now, because we're applying these inches here, you're now going to actually apply the same 10 gallon per acre total use that you used all the way up in our stream scenario. You have all those same inches, but you've stacked them on top. Your concentration is doubled, but your tank use is now the same as stream. In many cases, though, you may say, I want to save some, but I also want to invest some. So in that case, we're going to take some and keep it as dollars, and we're going to put some on top. So what would an example of that be? You could use a 15 gallon per acre concentration, this number here that we're using as that you're plugging into the iPad, because 20 gallon per acre would be a very high starter rate. So let's say we wanted to do 15 gallon per acre. Now, again, because we're 3 inches out of 6 inches, 7.5 is what we're actually spending. That's what the tank is seeing, what's coming out of the tank. So now our concentration could be here as a 15 gallon per acre total concentration with 7.5 actually being invested. So some savings, some investment. So when you think about how to calculate how much to load in your tank, it's a little different than in the past. In the world of stream, it's always the same as whatever your acres are times your rate. In our case, the math is easy when we do 3 inches out of 6, but depending on your row spacing and population, your actual average inches between seeds is going to change. You also have the option to do 3-inch or 2-inch dashes and even a custom dash length. So the way to calculate how much starter you actually need to load is to calculate the ratio of how many inches you're going to apply over the total average inches between seeds. So let's say that you're actually using 2-inch dashes, and you have a choice between 2-inch, 3-inch, or even a custom length. So that number could vary. And then you're going to want to calculate what is your average spacing between seeds for that field. And there's a number of different online calculators or charts that are out there, and that's going to be based on your row spacing, so let's say 30-inch rows, as well as your population. I'll just pick an example and say 28,000. So depending on what those two numbers are, that's going to give you your denominator. For our example, I'll just use something like 8.5 inches. And that's the distance between seeds. So now we're going to divide those into each other, 2 inches divided by 8.5 inches, and that gives us a ratio that we take times the concentration that we want to apply next to each seed. Remember, the concentration is actually the target rate that you're putting into the iPad. So for our example, we'll continue to use 10 gallon per acre concentration. So we'll take that times 10, and what we get here is for every acre, we're actually going to use 2.35 gallons. Okay? So when it comes to loading your tank, fairly straightforward. Let's just say we have an 80-acre field. So for every acre, we're using 2.35 gallon times an 80 is 188 total gallons that we need to put in the tank. So we'd load 200 or whatever it might be, and that should cover that entire field. So this ratio is the kind of math you're going to want to do in the future when you think about how you want to load the tank. And when it comes to setting the rate, you're going to want to think about what's your experience been in your fields and in your operation for the kind of concentration that you've run in the past with stream. Then, do you want to take it mostly as savings? Do you want to maybe invest a little bit more in those key inches right where the seed is at? You've got that ability and that choice to come down to what's the right concentration for each seed and what's it going to see and what are your total savings going to be as you use the dash system. Dash can really get you a lot of savings, and you can see that here if you follow the math even further and go back and say, what about when we were applying 10 gallon per acre, and so 10 gallons for every acre that was applied, again times our 80, well now we would have been 800 acres or 800 gallon that we're using in our tank compared to 188. So by using dash for this example, we've saved 612 gallon that we didn't have to buy, and that's what, a 76% savings. So the saving potential is huge, when you use Dash. You're in complete control of how much gets applied. When you then think about just the system in general and what your rate ranges are, what your choices are. Okay, we've designed Dash that, depending on your row spacing, your population, generally you're going to be able to run between 2.5 gallon per acre concentration up to 15 gallon per acre. We've designed the system to work for 15-inch, 20-inch, and of course 30-inch row systems. We've designed this Dash system to work really well with high-speed planters. And that's obviously the most challenging situation, that the faster the planter goes, the quicker the valve has to respond, the more challenging it is to make clean starts and stops to each dash. But we've designed the system to work anywhere from 4 mile per hour up to 10 mile per hour. And then we've obviously worked it so that you can run either water with some type of additive. In many cases that may be a biological. There's a number of products, as well as even be thinking along the lines of fungicides that are systemic, insecticides that we're applying in the furrow. These are all products that we have the ability to save, and those are generally water-based and being carried in water out to your starter type products, your 1034Os and those types of systems. So there's a number of different variables, and we've worked up and down the ranges within each one to make sure we're going to be able to hit those rates for you. And make sure to talk with your dealer or any of the 360 team if you have questions on any of the specifics in your operation. We're excited for 360 Dash to give you a new level of savings you've never had before in your starter operation, and a brand new level of control to be able to decide exactly how much product you want to apply and exactly where you want it to be relative to the seed. Thanks for taking the time to walk through these chapters with us as we've explained how 360 Dash works, how you set it up, how you install it, and how producers are going to be able to capture those savings without giving up yield potential.